What's up, y'all? Welcome to the very first video of Unit 2 of Math 1, all right? We are getting, honestly, we're really, when we're starting, we're kind of working off of what we already know, okay? So just so you understand, this video starts on page 3 of your packet. So if you're following along, please open up to page 3 in your packet, and we're going to take some notes, okay? The first thing I want to make sure we do here is I want to make sure we talk about some vocabulary, okay? So linear functions. We know a function is linear if the graph looks like the graph looks like a line. All lines are straight, so the graph looks like a line. The sequence is arithmetic. Ooh, I've seen something like that before. That sounds familiar. Also, if the pattern is adding or subtracting, all right? So what I want you to understand is, y'all, we already know this thing, okay? We're just using a different name now, okay? We know this situation is the same as an arithmetic sequence. So the pattern we've called in the past the common difference, and I want you to know that that is still in play. But we may start thinking about it a little differently, and we may actually use this other phrase called the constant rate of change. All right. But the idea, again, is that we're in an arithmetic situation. We're just calling it a linear function now, okay? So if we wanted to maybe have some sketches here, maybe I do a couple of sketches. Let's see here. I'm going to draw a couple little axes. Do another one. Okay. What we're going to do here is create something that kind of looks like a line. Well, what we did in Unit 1 is maybe we started here and maybe we did something like this. We had points, all right, kind of looking in a straight kind of line shape, but not necessarily a line, right? There were gaps. We just have points. The other option, though, and this is where we're kind of getting into some new stuff, is we could actually sketch in a line now, okay? And we'll get to a little bit more about that later on. Now, if we switch gears, and really I shouldn't even say switch gears, if we think about our other phrase from last unit, or our other type of sequence, right? We remember about sequences being geometric. We remember that those graphs look like curves. And we remember that the pattern is multiplying or dividing, which we called what? Yeah, I think I just heard someone say it. We have the common ratio. You might also hear the word constant ratio. But the big idea here is that we're now going to think about that idea or that concept as an exponential function, okay? So, what do those look like? Well, if I sketch another couple of axes, I could have something like this, right? Where we kind of curve down using points like that. But again, our new approach or the new thing that we may be seeing is actually having connected, not just points, but a connected kind of curve looking shape like that. Okay? So again, just a couple of new words. Linear functions and exponential functions. Okay. I'm not going to go back and look through the scenarios. That's something you can do on your own time. But again, what should you be looking for? You should be looking for if the points appear to be in a line shape or a curve shape, because that would go with linear or exponential. Now, our next couple of vocabulary words here: discrete functions and continuous functions. Everything we did in Unit 1, we just kind of used dots. And you know what? I'll be honest. I'm going to use the word points. But we knew that what we were doing, we couldn't connect our points. And the reason is because most of the things that we were talking about in Unit 1 were things that were countable, okay? Countable. When things are countable, what it really means is that you can't have parts of something. Or maybe that's a bad way of thinking about it, but Let's say, for example, we were measuring or counting people, right? You don't say that you have a part of a person, like 0.5 or 0.72 of a person. It's either 0 or 1 or 2 or 3 or 4. And so these things that are countable, you call discrete, and when you graph them, you just leave them as points. So something like, my bad, y'all. Something like this, right? Could have something like that. Or maybe once again, you have something like that, okay? And again, the idea is whatever we're measuring here, it could be people, it could be hamburgers eaten. These are things that are whole number ideas, things that you would count in full numbers, okay? Now, on the other side of it, though, the new thing that we're going to talk about here is when something is measurable, we incorporate this new word of continuous, okay? And what do we mean by that? Well, when you can measure something, these are the situations where now I would connect my points. And I'm going to describe that a little better in a moment after I kind of sketch my pictures, okay? So maybe I would start, maybe the first one I have some points. Maybe I do start by making some points, but then here I would say, well, if the idea is measurable, I would connect the points. Or maybe again, I have something that's exponential like this to start, but because it's something that I can measure, I would once again connect my points. Mr. Evans, what do you mean about this measuring idea? Well, I mean things like height, amount of rainfall, I don't know, anything that you can measure, right? Distance. When it's something that you would measure rather than count, you connect the points. And the reason is because it's okay. It is absolutely okay to be in between our points, right? I can be here, or I can be anywhere kind of in between because you're measuring it rather than just counting it as a whole number idea, okay? So we'll talk a little bit more about that and, of course, practice more as we continue on. Final set of kind of vocabulary here would be increasing and decreasing functions. I'm hoping that we may have some ideas on this, right? The word increasing usually means something's going up, just like decreasing is something going down. The key is that in both situations, we're always talking from left to right, okay? That's very, very important. Okay, so if something is increasing, that means as I start left and work my way to the right, the graph itself must go up again from left to right. Over on this other one, as we move left to right, now it should be decreasing, right? So maybe this one I'll do as exponential, something more like this. Okay. But that is something that continues to decrease or goes down from left to right. Okay, so that's a whole bunch of new vocab, but what I hope you are recognizing is that it ties back to what we've already kind of talked about. Again, and I know I'm kind of re-highlighting, we've seen arithmetic before. We've seen geometric before. We're just giving you new vocabulary words to kind of consider and use, okay? Okay. So finally, we do need to review one concept, and the concept that we are going to review today is called combining like terms, okay? Combining like terms is a strategy we use when we want to simplify an expression, all right? Well, Mr. Ravens, what is this idea like terms? I've never heard that before. Like terms are terms that have the same variable. And the idea is when there's multiple terms that have the same variable, you can kind of think about a couple of things or a few things as one combined idea. So let's do at least one example, maybe two. We're going to see how we're doing time-wise. But when I look in this box here, okay, the first thing I suggest you do is to stay organized. All right, and when I say stay organized, I mean use color or use different designs, and I'll explain more what I mean in a second, okay? What I'm going to say here, this 3x, this is my first term. I'm going to use a single underline, okay? I use a single underline. Now I know that any term that has an x in it, the variable x, I am going to also use my green single underline. So I continue on. Okay, I'm looking at this plus 2y, no. Ooh, minus 5x, that has an x in it, so I'm going to underline that. And I continue plus 6y, no, plus 9, there's no variable there. Okay, so I'm good with my x variables. Now I'm going to switch colors, and I'm going to change designs. I'm going to look at my next term, which is a positive or plus 2y. Well, that's cool. But as I move on to the next, I see another plus 6y. Okay, that's another y. And, oh, plus 9, no, that's its own thing, okay? So I would switch to one more color and one more design. Maybe I'll squiggle there. So what do we notice here? Hopefully you notice that we have two like terms that have x's, two like terms that are blue, and one final term that's kind of on its own, right? We wouldn't say it has any like terms. The big idea is that we can combine anything that's now a like term. So I'm going to combine these two ideas. I'm going to say if I have 3 x's and I take away 5 x's, that leaves me with negative 2 x's, right? Because 3 minus 5 is equal to negative 2, okay? And again, it's 3 x's minus 5 x's should leave me with negative 2 x's. Well, when I think about my blue now, I have positive 2 y's. I add 6 more y's to it. That leaves me with positive 8y. Finally, I bring down, because there's nothing to do with this 9, there's nothing to combine with it, I just leave it alone. And this is my final answer. This is a simplified version of my original expression. So let's do one more together, and then I'll save some for you to try on your own. Let's take a look at one, all right? So I start with my same strategy, right? Stay organized. I'm going to use color and different designs. I look at this 12x, and I notice, nope, negative 8 doesn't have an x. Negative 12 doesn't have an x. So that is my only x term. So I switch my colors, and I say, okay, I have a negative 8. That's just a number. There's no variable. I also have a negative 12 or minus 12 that also doesn't have a variable. And so those are like terms. Well, 12x, I can't do anything with. There's nothing to combine with it. But I have two numbers, we call them constants. I have two values that I can kind of combine together to think about as one idea. So if I have negative 8 and I subtract 12 from negative 8, if you have a calculator, of course you can use it, I know that that is negative 20. And now I once again have my final simplified expression. Okay? So that is what we need you to kind of take away from 2.1. Hopefully some of this is review. Hopefully we're okay with some of the new vocabulary. And of course, you should bring any questions that you have back to Math 1 the next time we see you. All right, have a great day. Peace out.